Welcome. Let us start our session for Earth's atmosphere. I am revising again. This is live session. So it is expected that you should observe playlist first. If not, then please check out session number 4. It is mentioned there that live session number 4, geography. In that, at end, you'll get playlist. Observe that all videos in playlist and then observe this lecture. All right. So it is expected that every day I'm giving you, that means every after lecture I'm giving you playlist. It is obviously taking time. First week, this problem was there that playlist was uploaded at late time, but today onwards we'll arrange it on same day. So it is not that after this session you will get immediately playlist right now, but reopen the video somewhere around evening, you'll get that playlist. Okay, so here you have to observe some playlist and then start observing this lecture. Now, as we are discussing about, this is civil services examination, so that thorough knowledge should be there. Here we are discussing in lectures first, and then again we are discussing here, say atmosphere. We are focusing here. Now, actually, by mistake, we are considering that where is the boundary of Earth. So suppose you are coming from space, then exactly where we should consider that you are on Earth. And for that purpose, we are concerned about the hard surface, rigid surface, where we can get land. So only thing that we consider here, that is land mass, or at the most we can say the water body, that is the Earth. Whenever we are talking the diameter of Earth, approximately 12,800 kilometer. So that 12,800 kilometer, that is actually diameter of solid Earth. But there is atmosphere, and that should be also considered, because if you are considering about Jupiter, then we are not very sure that Jupiter is having hard surface or not. It is covered in dense atmosphere. In case of Venus, Venus is also covered in dense atmosphere, but we are able to break through that, and rover, that means particular that probe that was able to reach on surface. So there is hard surface for Venus. So same way, whether Jupiter possesses that hard surface or not, it's not clear. We may guess that some hard surface must be there, but we are not 100% aware that hard surface is there for Jupiter. Then can we call Jupiter is smallest planet? So we have to consider that atmosphere. And from atmosphere only, we are measuring size. Now in case of Saturn, almost all it's clear that Saturn should not have any hard surface. If it is present, it should be very, very small. So like that, we are counting the boundary of planet from atmosphere only. So same thing is here. For Earth also, if you are considering the atmosphere, then Earth size is comparatively bigger. Okay. Now, atmosphere is consisting of various gases. And what is the altitude of atmosphere? Now, this altitude we are measuring from sea level. So, around 100 kilometer distance from sea level, atmosphere is present, answer is yes. Around 200 kilometer, answer is yes. Around 900 kilometer also, then also the answer is yes. Atmosphere present around 900 kilometer also. But the density of atmosphere is much more towards surface of sea. And as we are going away from surface of sea, the density of atmosphere decreases. Surprisingly, you'll find that whatever we are observing in atmosphere, that we are observing only in lower strata. Strata means layer. So lower layer of atmosphere only we are observing variety of things. When you are crossing out first layer of atmosphere, you'll find that the incidents taking place in that layer, they are something different than what we are observing from Earth. Temperature of atmosphere is not also constant. As you are moving up, initially temperature decreases. So this was biggest problem for me, that when we used to study, I was having concept this way in mind, that as you are moving high altitude, that means you are going closer to sun. It's obvious. So as we are going closer to sun, temperature should increase, and that's why Mount Everest should be hottest place, because Mount Everest is having highest altitude from surface, sea level, and therefore Mount Everest should be hottest place. But actually things observed, they are exactly reverse. As you are going at high altitude, temperature decreases rather than increases. Okay, this is called as lapse rate. Generally, for 165-meter altitude, temperature decreases by 1 degree. In some previous lectures also, live session also, I have explained this. For general calculation, we are considering for 160 meter, but for deeper knowledge, we are saying it is around 165 meter. So for 165 meter, temperature decreases by 1 degree. And for a calculation purpose, we are considering that temperature decreases by 1 degree by climbing up or going up 160-meter altitude. This is called as lapse rate. But the fact is that why this happen? Various reasons are there. I'm discussing the first reason here, that when sun rays are coming on Earth's surface, they are reflected, they are absorbed, and they are transmitted by atmosphere. Let me clear. This is surface. On surface, suppose this is incident radiation. Incident radiation is marked as I. This is falling. Then on that surface, three things are possible. First, that it is reflected. Now in that case, the reflection is considered as this way. This is called as normal. Normal means perpendicular to this surface. Then whatever the angle, this is called an angle of incident, and this is called an angle of reflection. So angle of incident and angle of reflection is same over here. So first case, that radiation here that I am telling you that increases, reflected out. But it is not that 100% radiations are reflected. That some radiation is getting absorbed here. It can penetrate through and absorb in this portion. And third case, that is thing that some radiations may transmit by changing its path. Now suppose this is glass. Then from glass, part of radiation is reflected, part is absorbed, and part is transmitted. So this way I can tell you that radiations when passing, three cases are possible. One is reflected, one is absorbed, and third is transmitted. You can check out say plain surface glass. For example, it is available for auto rickshaw or windshield of any car. You may see sun is shining over that. Something bright flash is coming out from that if particular angle is there. While that auto rickshaw or car is turning out, at some incident you may get something sudden flash in sunlight. This is the reason that part of light is reflected back by glass also. Why I am saying glass also? Because we are considering glass as transparent, but still it is transparent. Then also part of light is reflected by glass. So it's obvious that if 100 is the amount of radiation coming, something is reflected. So whatever is transmitted is not 100%. And so through glass, we can't say that 100% light is transmitted. Part of light is reflected. Part of light is absorbed. What is the evidence? Keep your vehicle in sunlight and touch the glass after some period. You'll find that there is rise in temperature of the glass. This is because radiations are absorbed and that energy is converted into heat. So you may guess that yes, part of light is absorbed and converted into heat. No doubt for glass, it is very, very less. Instead of that, if you keep metal sheet, then you'll find that metal sheet is getting hot quicker. Why? Because the reflected light is there, but transmitted light for metal sheet is not that much. Only in upper few layers. Say even you are aware that thin sheet of aluminum, we are calling it as aluminum foil. So through aluminum foil, sun is visible if sufficient thin aluminum foil is there. So in earlier part, we are getting that light is transmitted in metal also, but then it is absorbed. and so it is converted into heat. Whereas part of light is obviously transmitted, as I explained, that through thin sheet of aluminum, you can check out sun is visible. But tube light, ordinary tube light is not visible through aluminum foil. Usually we are using this type of aluminum foil for observation of sun and observation of solar eclipse. Solar eclipse can be observed by this type of thin sheets of aluminum. So part of light is reflected, part is absorbed. What is the evidence of absorb? That there is production of heat. So ultimately glass is getting heated. That means part of light is absorbed by that glass, and but very less. And then whatever the remaining that is transmitted, that's why you are on other end of windshield of car and you can see whatever is there in front side. That's why we are saying that radiations are penetrating also. So all three cases are possible, that part of light is transmitted, reflected, absorbed and transmitted. So this is about atmosphere also. So part of light is reflected by atmosphere, yes. Part of light is absorbed by atmosphere, answer is yes. And part of light is transmitted. Now whatever the absorbed portion is of high energy radiations. You are aware of these radiations now, gamma rays, X-rays, vacuum ultraviolet, ultraviolet. These radiations are high energy radiations. So they get absorbed. Say for example, gamma rays are absorbed in only upper strata. They are not coming to down. Okay. In normal case, range of gamma rays is around 10 to 12 centimeter. Range of X-rays is around 45 centimeter. So obviously both of them get absorbed in upper strata only. Whereas the vacuum ultraviolet also get absorbed in upper strata of atmosphere. Then ultraviolet radiations are there. Part of ultraviolet radiations are absorbed by ozone layer. Not all ultraviolet radiations are absorbed by ozone layer. Part of ultraviolet radiations are absorbed by ozone layer. And then remaining part is coming to the Earth's surface. That's why you can check out the D vitamin is synthesized under our skin, particularly when you are there in the sunlight of early morning. Sun should rise means at horizon 0 degree, and from that till around 15 degrees sun is coming. Whatever sunlight is there, that possesses very good amount of ultraviolet radiations. Because of that refraction, that radiations are coming, and that is producing or synthesizing that. Because of help of that, our skin is synthesizing vitamin D. Now that is evidence of ultraviolet light. Otherwise simple, you can check out any fluorescent color. Now you are aware that jackets are there fluorescent color, pens are having fluorescent color, you may have marker pens having fluorescent color. If that fluorescent color appear bright, then there is presence of ultraviolet light. If that light is not, that fluorescent color is not appearing bright, that means there is less number of ultraviolet radiations in that room. All right. So our ordinary tube light also contains that emits ultraviolet radiation. LED lamps are also emitting ultraviolet radiation. Ordinary white LED, that is also emitting out ultraviolet radiation. If you are switching off all the light, but in the room, suppose sunlight is coming out by reflection, not direct sunlight, by reflection, we are calling this as diffused sunlight. So in that diffused sunlight also ultraviolet radiations are there. So what ozone layer is doing, that certain ultraviolet radiations are harmful. These ultraviolet radiations are absorbed by ozone layer. Not all ultraviolet radiations are absorbed by ozone layer. Is that clear? Now we are going to further that radiations coming to Earth's surface, they are visible. What is the best evidence? That you can observe sun, you can observe moon, even you can observe various planets and distant stars also from surface of Earth. That means light coming from these stars, light coming from these planets, light coming from this sun, moon, everything is coming on surface of Earth. Because of that, you are able to observe them, and that's why we can say that radiations are coming on surface. Now, what happened on falling these radiations on surface? Say, for example, sunlight is falling on surface. It will be reflected back by Earth. Answer is yes. Just we discussed in previous lecture only that dark side of moon is not 100% dark. You can observe it is in reddish color. That's why we can observe crescent moon, and other part of moon in somewhat dull color, that is light reflected by Earth. that is falling on moon, and moon is again reflecting back, and that is coming on earth again. So that light is there. So as earth is visible from space, that means light is emitted by or reflected by earth's surface, and therefore I must say that yes, there is light, part is reflected, but part is absorbed in atmosphere and remaining is reaching to surface. Surface will also transmit sunlight to certain part. Say for example, that surface is water. Then in water, sunlight can pass till around 600 feet. Now they are using some different unit that is called as fathom. So till 100 fathom depth, sunlight passes. So suppose you are going at deeper side of ocean, where depth is greater than 600 fathom, then you will not observe anything, it's dark. But from that dark, suppose you are coming in upper layer of 600 feet, that is 100 fathom deep, then you can observe sunlight. All right. So sunlight is absorbed by water and transmitted by water also till 100 fathom, that is 600 feet. In land also, in upper strata, sunlight is passing out. Then onwards, it is obviously opaque, so sunlight is absorbed. After absorption, you are aware it is converted into heat, and once it is converted into heat, the next stage is that it is reflecting, it is radiating out that heat. We are calling these as heat radiation. They are in range of infrared light. So this infrared light is there on surface of Earth, and from that it is emitted throughout. Now, initially, certain gases are there. There are water vapors, carbon dioxide, and methane. These gases are capable of absorbing this infrared light. They absorb this infrared light, and therefore, by absorption of light, their temperature rises. Getting idea? And so, the one which is on Earth's surface, exactly suppose I am talking of land or sea, then in vicinity, that atmosphere is getting hot. As you are going to upper layer, the radiations are already absorbed to greater extent, and water vapors amount decreases as you are going ups and ups. Carbon dioxide amount also decreases as you are going to upper layer. The absorption of radiation also decreases. Secondly, that is, atmosphere is not capable of absorbing visible light to that extent, and therefore there is fall in temperature. Okay, so this is first reason that why temperature decreases as we are going to high altitude area. Now, another thing, I'm just shifting somewhat to chemistry side or physics side. There is a process which is called as adiabatic process, or rather here the applicable process is adiabatic cooling. So if you are from science side, if you are aware of thermodynamics, you will get easily. Otherwise, I am explaining this concept that when we are pressing out something, that is compressing out, or rather work of compressor. When we are compressing out something, then obviously there is rise in temperature. Say what I am using word, when you are compressing out something, there is rise in temperature. When you are releasing out pressure, the gases tends to expand, and in that case of expansion, you will find that temperature decreases. Check example. I will show you simple example here. This is our room freshener. You are aware that some gas is compressed here, along with some liquid that we are calling as room freshener. When I am pressing out nozzle, the pressure decreases. Why? Because some gases are going out. Because of that, pressure inside the container decreases, and you will feel that this container, just touch out, you will get idea that container is getting cold. If you are using deo, then also you may experience same thing, that when you are using deo, then also when we are pressing out, when deo is coming out, temperature of cylinder decreases. This is the reason that on compression, gas is coming out, but then inside pressure decreases. That is accompanied by cooling of that, because for expansion work, so ultimately gas is coming out. That means some work done is there. For that purpose, energy is required. From where energy is taken, that is from that system only. And therefore, temperature inside the container decreases. Other than that, if you are not using DO, that good. Then you are not using this type of pressurized container. Then also another example, because God has provided many things. So I will give you one important example here, that your mouth is actually compressor. We can use our mouth. We have sensation here. So we have thermometer here. I will just put here my hand. You can do along with me if you want, and blow. Feel the touch. Whatever air that coming out from your mouth, just feel the touch. You'll find that temperature is high. You may explain this way, that yes, from our lungs that air is coming out. Then from our entire trachea and mouth cavity, that is buccopharyngeal cavity, that air is coming out. Yes, where temperature is maintained to 37 degree, and therefore we'll feel it is warm. This is one reason. But another reason is that in your mouth, when your lungs are pressing out, diaphragm is moving up, lungs are pressing out, then there is production of high pressure here. And because of that high pressure, we are getting the touch as warm. If that 37 degree argument is valid, then just check out this way. Keep your hand or palm away from your mouth, nearly 1 feet. So I'm keeping it around 1 foot distance, and blow air now. Feel the touch, it's cold. Why it's cold? Because air is compressing your mouth, but then onwards it is coming out. Now we are giving here sufficient space that air is expanding out. What is coming from your mouth? For expansion, work done is there. If work done is there, then for work done, energy is required. That energy is taken within the system, and therefore on expansion, temperature decreases. Because that heat is taken from system for this work done, and temperature falls down. This is called as adiabatic cooling. So no external heating is required or external cooling is required. Within the system, heat is lost for work done. Then this type of cooling is called as adiabatic cooling. I hope you must have understood this all concept. And then you can check out, as we are moving in upper layer of atmosphere, temperature decreases. For reason number one, that radiation theory. Reason number two, that as we are moving in upper strata, pressure decreases. Atmospheric pressure decreases. Say for example, if you are visiting out Himalayan section, for example, you are going for Manas Sarovar Kailas mountain yatra. The problem is that areas over there is having greater than altitude 5,000 meter. 3,500 meter onwards, atmospheric pressure is considerably low. If you are crossing out altitude of 5,000 meter, then obviously pressure is too much low. If you are visiting Mount Everest, if you are that lucky, and then you'll find then we have to require some external help. That is oxygen cylinder, mask, etc. We have to get used. Then only we condition. Yeah, there are people of Mount Everest without oxygen cylinder. I salute to them. But for ordinary people, we required oxygen cylinder if you are climbing, because Mount Everest is greater than 8,000 meter altitude. 8,848 meters something altitude is there for Mount Everest. And therefore, when we are going at high altitude area, pressure decreases. That means air, if it is at lower layer, then pressurized air. As we are moving in upper part of atmosphere, pressure decreases. That's why when we are traveling by aeroplane, now what aeroplanes are there? They are called as pressurized aeroplane. Why they are called as pressurized aeroplane? Because they are flying above 10,000 meter height. Above 10,000 meter height means even greater than height of Mount Everest. You are traveling now. And at that condition, as a simple ratio I will tell, because many times these heights are explained in terms of feet. So absolute calculation with help of smartphone you can do, but otherwise for simple thing, divide whatever the feet by 3. Approximate meters distance you will get, approximate. So planes are flying above 10,000 meters, so obviously outside atmospheric pressure is low, and then inside the plane pressure is maintained by special equipment, that is at sea level only water pressure is there, that pressure is maintained within the system, and therefore we are calling the pressure that aeroplanes as pressurized aeroplane. It is not something pressure is there in engine. Pressurized aeroplane means pressure is there in the passenger compartment, pressure is maintained. That's why. Okay. So we are discussing about pressure. So as you are going and going to upper part of atmosphere, pressure is less. Because of that decreasing pressure, air is tending to expand more and more. And because of that also cooling is observed. Then that cooling is called as adiabatic cooling. So as you are going away from sea level, temperature decreases first because of this infrared radiation, and second, that is because of adiabatic cooling. It is not that we are approaching closer to sun, therefore temperature is rising out. That's why you'll find that snowfall is possible on equator. Only thing is that we have to go to altitude greater than 4,800 meters from that. Such mountain is there on equator, that is called as Mount Kilimanjaro. In Africa continent it is there. So if you are going to Mount Kilimanjaro, then you can get that ice or snow on equator because its height is greater than 5,000 meters. So this way we are going in upper strata, temperature decreases, but these all things happen only till first strata of atmosphere, that is around 16 kilometers. This strata is called as troposphere. You must have noticed that graph in lecture. You have observed that graph. So that graph shows you that what is the border of troposphere. It is very less in polar region. So if you are traveling in polar region, then altitude of polar region, that altitude of troposphere here is just 8,000 meters. That means 8 kilometers. And on equator it is bulging out. So on equator it is 16 kilometers. So suppose this is the Earth. Then this is the, I can show approximately troposphere. So in polar region it is just 8 kilometers, and in equator it is 16 kilometers. Now question is that when we are going to Mount Everest, it is greater than 8,000 meter altitude. There are some more than 100 peaks in the world. They are of altitude more than 8,000 meters. More than 100 peaks are there. Somewhere 107 or something, I don't remember exactly. But around 107 peaks are there. They are above 8,000 meter altitude. So if you are there on that peak, then can you cross troposphere? Answer is that out of that 100 and whatever that peaks are there, out of that more than 95 peaks are there in Himalaya only. You are aware that on Earth, location of Himalaya is somewhere here. So obviously it is not on polar region. Some students are having concept that Mount Everest is on North Pole or Himalaya is on North Pole. No, the cold is there. That is because of higher altitude you can experience cold in Himalaya, but it is not on polar part. It is somewhere around this part. And so here troposphere is not of 8 kilometer height, it is greater than 8 kilometer height, and therefore you will find that when you are going to such peak, then you are not crossing out limit of troposphere. If you are going away from troposphere, higher altitude, then you will get that troposphere is having temperature continuously fall. But then onwards, you will find that whatever you are going to higher altitude, temperature will remain same. So whatever theory I am explaining, that is not working. Temperature will remain same. In that case, we are calling that strata as tropopods, where temperature remains constant. Then we are entering into next strata, that is called as stratosphere, where temperature start rising again. Now, first temperature decreases, everything you listen. Then what is the reason that temperature rises in stratosphere? The reason is that this layer is having lack of water vapors, rare carbon dioxide, because already carbon dioxide is very low in atmosphere, in around 0.3%. So it's very, very less carbon dioxide is present in atmosphere. But apart from that, you are going to high altitude, carbon dioxide amount decreases. Carbon dioxide is having more density than air. And therefore, always keep in mind, in a closed room, if room is entirely closed, then carbon dioxide forms lower layer of that room. Upper layers are of less carbon dioxide. Lower part of room is having more carbon dioxide because carbon dioxide is having more density. That's why you can check out that in new local railways designed, given for Mumbai, their lower part, they are kept open. So there should be movement of atmosphere, particularly carbon dioxide is accumulating because in Mumbai, trains are overcrowded. I'm not talking of crowded. They are overcrowded, particularly during peak hours. Overcrowded means literally some people not allowed, but they travel on the roof of railway. So that's why I said that they are overcrowded. And in that case, obviously, everybody is exhaling out carbon dioxide. That carbon dioxide accumulation is more. In old train, there were compartments. Packing was there. Here, whereas new design, they are having only bars as separator. So ventilation is very good. But particularly, they kept at lower part, they kept open part. Because of that, there is drift of air when train moves. And then carbon dioxide is not accumulating over there. But if you are igniting out candle, then you will find that carbon dioxide is going up because that is hot carbon dioxide. And that's why it is going up. Let it be at room temperature, it will come down only. So in stratosphere, very less carbon dioxide, almost 10 to 0 carbon dioxide is present in stratosphere, where you will find here an allotrope of oxygen. So what is allotrope? Chemical formula differs, but symbol is same. So you are writing, we are aware that we are writing oxygen like O2. So allotrope of oxygen is formed having formula O3. It is formed from oxygen only, and it absorbs ultraviolet radiation. And now you are aware that when radiations are absorbed, it is converted into heat. And this way, you'll find that heat is produced over there. Now, you'll find that as you're going up in stratosphere, heat is more. But that more means don't consider that temperature is above 100 degree and all that. Temperature will reach around 0 degrees Celsius. So already till 16 kilometer temperature is below 0. Then onwards temperature rises again till 0. Again, you are going to higher height. You'll find that temperature remains constant. This is called as stratopause. Like that, layers of atmospheres are there. You have to study. Now, remaining things you can observe previous lecture, that is live session number 4, where playlist is given. And in that playlist, you can check out for other layers of atmosphere. Only I am mentioning here the uppermost layer of atmosphere, that is called as thermosphere. In case of thermosphere, temperature is too much high. At daytime, more than 1000 degrees Celsius temperature is there in upper part of thermosphere. And at night time, it is reaching to 250 degrees Celsius. This is actually protection layer of Earth. You will find that what meteorites, that means whatever the astral bodies are there, stones, and we are calling it as dust. Actually, dust means not fine dust, they are stones. They are coming. They are ignited at upper part only. And that's why you can observe meteorite fall. At we are calling this as shooting star. So at night, if you are observing sky, you may find that star is falling down and suddenly it disappears. This is not star is falling out. This is what the atmospheric dust is there. Not atmospheric, in sky. Dust is there that is entering in atmosphere. In upper strata only that is burnt out. And then if that stone is sufficiently big, then you can observe longer path. Can it reach to surface of Earth? Answer is, for that purpose, that stone should be sufficiently large in size. Then only it can reach. it is said that per day around 10,000 stones are reaching to surface of Earth from sky. Earth surface is quite large, therefore 10,000 number is less. But this is the fact that around 10,000 stones per day are reaching on Earth's surface. But by reaching, they get burnt off to such extent that they are extremely small at that time. But sometime, if sufficient big stone, we are calling that as asteroid, that is coming in contact with Earth's atmosphere, then after burning also, it can reach to surface of Earth and it will create impact on Earth. We are calling this as a crater can be formed. So in Russia, particularly Siberian part of Russia, such incident happened in 20th century. Huge explosion was there because of falling of meteorite over there. But fortunately, in Siberia, density of population is very, actually, we should not call their density, we should call it as rare city of that population is very rare population. And therefore, you will find that destruction was not there that much for human being, but for Earth, it is much more. Such incident happened in India. Answer is yes. In past, such incident happened in India also. In state of India, that is Maharashtra, district is Buldhana. In Buldhana district, this incident happened. A great meteorite fall on the surface and produce a crater. Something you must have observed crater on Moon, on Mars, on Mercury. A similar sort of crater is produced here in Buldhana district. Name of place is Lonar. You can check out that. That is called as Lonar Lake. For many years, these scientists were having doubt that this crater is volcanic crater or by meteorite. But now scientists concluded that this is meteorite crater only. So like that, craters are formed because of this type of meteorite. But for that purpose, that meteorite should be sufficiently large. Otherwise, you'll get that meteorites are burned into upper parts of atmosphere. We are calling that layer of atmosphere as thermosphere. Therma means heat. Then upper part of atmosphere, that is having, because of such high heat, atoms are in form of ions. And therefore, we are calling this layer as ionosphere also. So ions are present, therefore it is called as ionosphere. And then you are aware that when we are using radio communication, I don't know how many of you are aware, because now we have everything on internet available. But in old days, we were using radio, 4-band radio like that. Out of that, one we are calling as MW, that is medium wave. One we are calling as short wave. So out of that, these short waves were reflected by, are reflected by ionosphere. And therefore, we can able to hear distant radio stations if they are there on short wave. Otherwise, you are aware that particular radio station will have definite area. In that area only that radio signal can reach on surface. But if they are using short wave, then short wave communication can be there from other part of continent also. That's why when our great freedom fighter Subhash Chandra Bose went to Germany, he started giving speech from German radio that can be audible in India, because that communication is shortwave radio communication. So short waves are reflected by upper part of atmosphere. That is, we are calling it as ionosphere. Then you are aware of carbon dating, a technique that is used for detecting out age of sample, age of that specimen. Say for example, at Mohenjo-daro Harappa, whatever grains are obtained, we can check out that with carbon dating technique, and then we can determine the age of that particular specimen. Now it is coming around 5,000 years. Then we have to say yes, at 5,000 years they were present. Now this way, that carbon dating technique is used. For that also, upper part of atmosphere is required. So this way, we have upper strata of atmosphere, which is consisting of ionosphere, Then certain radiations are produced from that. We are calling them as cosmic radiations and all that. Now, many students are having questions in mind that when we are talking about artificial satellites, do satellites are crossing out limit of atmosphere or not? You're aware various types of satellites are there. Some satellites are called as polar satellite. So this is North Pole, this is South Pole. They are having orbit like this. If they are orbiting like this, then they are called as polar satellite. See, here is the India in front of you. If we are having polar satellite, it should move like that. But while this motion, Earth is moving. And because of that, you'll find that polar satellite is not throughout the way on your country. It is continuously changing out location. So Earth is also moving and the satellite is also orbiting. So around 90 minutes per orbit is taken. And then it is not always that when that satellite is passing here, that India should be there. Okay. And like that, satellites are there. We are calling them as polar satellites. Now, when we are launching these polar satellites, they are having very low orbit satellite, middle order satellite, like that satellites are there. When we are talking of very low orbit satellite, they are at range of 100 kilometer onwards. The problem is that when these satellites are there, they are facing out some friction because of atmosphere. But at that time, atmosphere is very, very low. So whatever we discussed, that what are the major portion of atmosphere that is in 16 kilometer from Earth's surface. Then atmosphere decreases, pressure decreases, and ultimately atmosphere is present but in very, very rare form. And so these polar satellites, they are flying, particularly low orbit polar satellites, they are flying in range of atmosphere only. But if satellite is going above that range, then it is having very, very less friction because of this atmosphere. And another category of atmosphere, this satellite is there, that is called a geostationary satellite. So just I told that polar satellite, to launch that vehicle is used, that is called as PSLV. Geostationary satellite, to launch them, we require a vehicle that is called a GSLV, that is geostationary launching vehicle. Now see here, geostationary is the concept. For example, this is India, where we are making one circle around Earth within 24 hours. Actually, 23 hours and 56 minutes some second, but let us consider here 24 hours. Then satellite should be placed here like this, that along with Earth's orbit, it is also orbiting around Earth. So as Earth rotates, it is orbiting around Earth. So from India, if you are observing, then this is the way satellite is also moving. Okay. So it will be there constantly on India only. So we are calling it a geostationary. From Earth side, this is stationary, but not actually stationary. It is in motion. For this type of satellite, orbit requires that is around of 36,000 kilometers. And so absolutely it is away from Earth's atmosphere. Because what they say, that maximum altitude where atmosphere is detected, that is around 9,000 meters. Extremely rare atmosphere is detected there, but otherwise you can keep in mind that major incidents in atmosphere occur only in lower strata, that is 16 kilometer altitude, that is called as troposphere. Then onwards atmosphere decreases considerably as you are going to higher altitude, and ultimately it's very, very, very rare. Now you are aware that in between sun and earth also, we are saying that atmosphere is not there. There is a vacuum, but it is not a perfect vacuum. Sun is emitting out charged particles, they are scattered in between. And like that, 100% vacuum is not there in the space also. All right. That is in the vicinity of sun. When you are crossing out exact border of solar system, then you may say that there is perfect vacuum, if at all possible. So we discussed something about this atmosphere's layer. This is only, we discuss layers. Now composition of atmosphere. We are having fear continuously that amount of carbon dioxide is increasing, and amount of oxygen is decreasing. The real fact is that in evolution process of Earth, on once upon time oxygen was very, very less. Carbon dioxide was more. Because of these autotrophs, that is plants having chloroplasts, they converted carbon dioxide into oxygen to greater extent. Oxygen was pollutant in old days. Now oxygen is required for life system because life changed in this way that it started getting dependency on oxygen. Now carbon dioxide layer is no doubt, we are saying that carbon dioxide increases, but other factors are also there. Carbon dioxide is largely absorbed by water, and then it is used by plants in water. We are calling them as phytoplanktons. So they are used by these phytoplanktons. And then carbon dioxide layer is very, very less. You can check out in the composition. The dry air, that means if you remove oxygen, if you remove water from air, then whatever the air is there, in that the maximum important component here is nitrogen. It's 78% nitrogen is there. Nitrogen is reactive gas. Answer is yes. Nitrogen is extremely reactive gas. When nitrogen atom is single, so I am showing this is as nitrogen. Then nitrogen is extremely reactive. It is so reactive that if another nitrogen is there, then it is immediately reacting with nitrogen and form bond. The three bonds are formed between nitrogen and nitrogen. And then they are giving here a molecule, we are calling it as N2. Now this N2 is strongly bonded between both. Now in order to carry out further reaction, suppose we want to make reaction, then we have to rupture these bonds first. And then they can react with other. For that, energy requirement is very high. And therefore, in N2 form, nitrogen is almost inert. I'm not using word as inert. I'm using word as almost inert. That means it is not taking part in reaction to that extent. And that's why nitrogen is serving as inert atmosphere for Earth. So this nitrogen gas is around 78%. Then obviously second abundant gas, that is oxygen. Oxygen is abundant element in Earth crust also. Whereas oxygen is abundant gas in atmosphere, but second abundant gas in atmosphere, nearly 20% oxygen is present in atmosphere. Now see, oxygen is reactive, answer is yes. Which oxygen? O. But O is forming double bond with another O to give compound that is called as O2. And O2 is not that reactive, but not as inert as nitrogen, but not as reactive as other gases like itself, O. So O2 is moderately reactive. Particularly our life system depends upon this O2. So in Sanskrit we call it as prana vayu. So life system is depending upon O2. So second abundant gas is O2. I'm not counting water vapors. The third abundant gas, surprisingly to know, it's argon. It is also inert gas. And at fourth number there is carbon dioxide. Now we are discussing about carbon dioxide because many students are considering this as important. So today world is also concerned about the rising level of carbon dioxide. But the reality is that in some part only these layers are rising. For example, a city like Mumbai, Delhi, you may notice that during winter season, Delhi is facing tremendous problem of pollution. At that time, carbon dioxide level may high. Okay, but soon it get localized, delocalized and then stabilize also. Today we are saying a concept of global warming, but I feel personally that some international multinational companies, they are creating out this type of issues. Why? To change out engine of your car. Carbon dioxide layer increases, global warming is there. You can check out previous 100 years data, you'll find that Earth's temperature is rising. But what is opinion that only it is not because of carbon dioxide? Various other factors are also there. Say, for example, sun may give more heat or less heat. That factor. Earth's axis is little bit tilted by 23 degree, but some observations are showing that that tilt can extend to very great extent also and less also. That is also matter, because on Earth, 4 ice ages were there. Bigger ice ages were there, they were 4. And we can check that first ice age is vanishing and next is coming. That means temperature is rising. Again it will going to ice age, that means again temperature is falling. Again ice age will over, that means again temperature is rising. Our presence on Earth is from end portion of 4th ice age. That means we means human, are not responsible for rising temperature for first 3 ice ages, and obviously for 4th ice ages also. That why temperature was rising. So other than carbon dioxide evolution, various other factors are also there. We have to consider them. So only thing I am discussing here, some facts regarding these layers of atmosphere and composition of atmosphere. No doubt certain gases are produced by burning fossil fuel. They are not good. Fossil fuel means fuel obtained from our ancestors particularly. So petrol, diesel, coal, all these things, CNG, LPG, all these things where CNG is compressed natural gas consisting of methane to greater extent. LPG is liquefied petroleum gas consisting of butane and isobutane mixture. So like that are obtained. They are obtained from remains or fossilized part of the previous world. So maybe possible plants, animals, whatever. Anyway, so these are all things we are burning out. That means whatever the carbon dioxide is trapped in the system, that we are releasing out. Okay. And so plantation of new tree is another option that will absorb carbon dioxide and retain as in form of wood or food. Some say that cut down the forest and plant new tree. Why? Because when tree is already in existence, it is shedding of leaves and then produces more carbon dioxide by that decay process and all that. Instead of that, cut that tree, convert it into furniture. That means carbon dioxide will get trapped in that wood form, and plant new tree that will take more and more carbon dioxide for growth. And this way we can control level of carbon dioxide. So like that, various theories they are putting forward how to keep control over carbon dioxide, rising level of carbon dioxide. But the most important thing, that modernization process or industrialization process is important for rising level of carbon dioxide, if at all. Okay, so I'm concluding this discussion because I'm not able to cover all 5 videos here. So this Wednesday also we have lecture online. So in that online lecture, we are considering that whatever the remaining videos of the same same playlist, the remaining videos we are discussing over there. So be ready on next Wednesday at 11 o'clock. Thanks. I'm displaying playlist here also again, but you will observe that playlist after evening. Thanks.